In this video, we will look at the repeated nearest neighbor algorithm, RNNA. So we've already looked at the nearest neighbor algorithm. You might recall that from the previous video where we pick a starting spot. We choose the next place by what's the cheapest without repeating until we're done with the circuit. Well, all we're going to do is update this to say the repeated nearest neighbor algorithm is do the NNA, do the nearest neighbor algorithm, starting at each vertex. So if there's 4 vertices like A, B, C, D, you would do it 4 times. And then you would choose the one that gave you the minimal weight. Okay, so let's take a look at this example. This is an example where we have 5 cities, A, B, C, D, E, and we have the traveling costs between the 5 cities. So in this problem, we would need to do it 5 times because there are 5 vertices. So I would either start at either A or B or C or D or E. And then I would use the nearest neighbor approach each time. So let's try it. Starting at A, what is the cheapest route out of there? Well, I can go 133, 152, 119, or 185. So it's pretty obvious the cheap one of those is $119. So we choose the 119, all right? And so we go from A to C, and we're just going to kind of continue our way around that. The next one from C, the next cheapest route, looks like it's going to be $120 to go across to E, all right? So I'm going to go next to E. Now I only have 2 more cities to go to, either B or D. Of those 2, D seems to be the cheaper at $199, all right? And then since I visited every city but one, I have no choice but to go to B next, and that's going to be $150. Now that I've visited every city, remember it is a circuit, so you have to start and end at the same place. I must go back to A where I started, which is actually $185. Now, what is the weight of that? Would just be the total, the sum of all of the edges that I travel down, all right? So in order, it's 119 plus 120 plus 199 plus 150 plus 185 is 773, in this case, dollars. All right. So is there a cheaper one? Well, there might be, and there might not be. So in this algorithm, what you're basically going to do is consider all the possibilities and see which one's the cheapest of these 5 right here. Okay, so if we start at vertex B instead, you can see I've paused the video and filled it in. The route looks like this, BCAEDB, with a different weight of 722. You do have to come back on this last route there, so you have to add in that last 150. Let's take a look at the next one. Okay, at this point, I've done 2 more, and you can see that I did the route starting at C and D, and they have a different weight, but C does match B. So I'm pausing to take a look at this graph here. You can see how it kind of looks on the screen. And that one is the worst so far at $776 if we start from D. So let's do the last one live together here, starting at vertex E. We start at vertex E. Again, there's 4 options. And the 4 options are 133, 200, 120, and 199. Our cheapest route is the $120 route to C. From there, the next cheapest route would be to travel up to A at $119. Now we only have 2 places left to go. Let me update my letters. So far, I went from E to C to A. Notice I have not yet visited B or D. So from A, the cheapest is actually D. All right. And then I have no choice but to go back to B and then back to E. Notice this is a different looking route. It looks like a star. Let me update it. After I went from C to A, I went to D and B and back to E. Now, if I add up all of those weights, starting from E to C, it's 120 plus 119 plus 152 plus 150 plus the 200 to get back, 741. All right, so my best 2 routes using the repeated nearest neighbor approach, again, I had to repeat it, I had to do it 5 times, were these 2 at $722. Now, what you'll notice is actually they are the same circuit, just listed in a different order. All right. And so let me show you what I mean by that. Well, if you would highlight those, let's highlight this first one right here, BCAE. So it starts at B, goes to C, and then goes to A. Let's see, A, E, D, and then back to B. All right. So that's kind of the shape of it like that. If you look at this next route right here, I'll do it in red. If you start at C, you would go A, E, and then D, and then B, and then back to C. Notice it's exactly the same traced route. And you might remember this from before, but it's just the letters in a different order, okay? In the first one, B, C, A, E, you can see here in the second one, B, C, and then it would kind of morph back to here, A, E, D, B, right? D, B. And so there it is. Now, if we think back to this problem, from the one from before, we oftentimes have a starting city. And so this is my best route using R, N, and A, like this is my best circuit. But I might then figure out, well, where exactly does the person originate from? Let's say that they lived in city A, right? So then I would write down this circuit from A. Now, of course, if you use the nearest neighbor approach from A, it ends up not being the best answer, right? But we can rewrite this route using the traced lines here. So if I start at A, right, if that's my home city, then I can just go around to E, to D, to B, to C, to A, E, to D, to B, to C, to A, and be assured that it's the $722. Again, how did I get those letters? Well, it's the same traced route, and you can see up from above, there it is, A, E, D, B, C, and then ending back at A is the same exact route. So that is the repeated nearest neighbor approach. Now, we visited this problem in the last video where Darren was traveling to all these cities. Now, if you're going to do this problem with a repeated nearest neighbor approach, what you might find is a better answer if you start at Atlanta versus if you start in Columbus versus starting in Kansas City, Minneapolis, Pierre, and then Tulsa. You'd have to do this problem 6 times, and repeat that nearest neighbor approach. When you got done, of those 6, there may be some repeated routes. They may be all different, but whichever one was the least mileage, we would consider to be the repeated nearest neighbor winner. And that is how we will choose our winners.